Okay, everybody. So today we've got a couple more sections to kind of talk about before the end of the trimester. We're still dealing with the equations of lines. Before we get into the new stuff for today, just a couple of reminders here. If you didn't get me the gold sheet on Friday, make sure you have that ready for me tomorrow when I'm back. I still need to collect that from a few people. And then the second thing would be to check Infinite Campus. If there's anything in there that's missing, especially when you look at things like the quizzes and tests, they'll say things like 1 point or 5.1 through 5.4 quiz or 6.1 through 6.4 test. If those things are missing or if they're marked as not proficient, those are things you really, really need to get made up to make sure that your grade is where you want it by the end of the trimester. Down here, you've got just what we're doing kind of the rest of the trimester. Today and tomorrow, we're working on section 6.6. Wednesday and Thursday, we're working on 6.7. And then on Friday, we're taking a short quiz over those two things, just those two topics, not even the other stuff with them. And I believe the plan right now is that will be a Canvas quiz, but we'll kind of see how that goes. So you should all have the white sheet that has 6.6, the point slope form of a line on the top of it. If not, make sure you kind of get that before you move on here because we're filling that out as we go. And then just at the beginning here, a couple little reminders of things that we've done earlier on that we're going to need to be able to do today. The first one here is the distributive property. And so if you remember, the distributive property comes into play when we have something multiplied by some addition in parentheses. So normally we'd have to add the x plus 3 first, but since we don't know what x is, we can't actually add those together. The distributive property lets us simplify that by multiplying the 2 times both of the things in the parentheses. And so 2 times the quantity of x plus 3 is going to turn into 2 times x plus 2 times 3, which is 6. And then the only things you really have to be concerned about after that are just positive and negative signs. So here I'm taking the 2 times x, so that's still 2x, but this time I'm taking 2 times negative 3, and so that's going to be negative 6. When we got the negative out in front, I'm just taking negative 2 times both of those things. So negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. And then be really careful when we have a lot of more negatives here. Negative 2 times x is still negative 2x. But now we're taking negative 2 times negative 3, and that actually gives us plus 6. So you'll see where that shows up pretty soon here. The second thing we're going to need to remember how to do is deal with finding the slope between 2 points. And so the first thing we want to review here, or remember here, is just what the slope formula, what the slope formula is. And so that was the one that was y minus y1 over x minus x1. And so x and y are one of the points. We usually just use that, x and y. Doesn't really matter which one. And then y1 and x1 is just the other point. Really big important thing on these is that negative sign, that subtraction is part of the equation, part of the formula. And so if you're subtracting negative 4, it's going to be minus negative 4. And then we use m. Oops, I don't know why I did that. We use m, so that equals m, the slope. So as an example here, we're finding the slope between these 2 points. One thing I found or I've seen that's helping a lot of people if you're having some trouble with this is they're drawing lines. So they're starting with 3 to negative 2, and that's the y. So I'm taking 3 minus negative 2. Basically, how far is it from 3 to negative 2? Then on the other side, I'll do this in even a different color here. For the x's, I'm going from negative 4 to 2. So negative 4 minus positive 2. Then we can go ahead and simplify both of those things. So 3 minus negative 2, we're going to change that into a plus. 3 plus 2 is 5. And then on the bottom, negative 4 minus 6 is, negative 4 minus 2 is negative 6. I got a little bit ahead of myself there. And so we always will write the negative not in the bottom. So we'll always write like negative 5/6 as our slope. Okay, so those are the things we got to be able to do. Let's take a look at point slope form. So the first thing we're going to do here is we're going to rearrange the slope formula. So we're actually starting with this equation, m equals Let's do purple. Why not? Okay, we're starting with this equation m. Come on, pen. Try and do this on my pen here. There we go. So we're starting with the equation, basically m equals y minus y1 over x minus x1. And what we're going to do here to rearrange this is something we haven't really done a whole lot of yet, but we're going to actually be multiplying both sides of the equation by x minus x1. That is something that we're allowed to do. It's not something we really do a lot when we're just trying to solve equations, but as long as we're multiplying both sides of this equation by the same thing, that's okay. And just like anything else, if I'm dividing by x minus x1 and then multiplying by x minus x1, they cancel out on that side. And then on this side, I'm just going to leave that alone. And then I'm going to go ahead and flip it around a little bit here. So my final equation that I end up with here is y minus y1 equals m times x minus x1. And that is called the point-slope form of a line. I wrote the word form twice. Point-slope form of a line. And you'll kind of see here why we call it that. It's a really nice form that we can use. And so the big thing here, and we got this form, the x and the y, just like in our slope-intercept form, just like in every equation with x and y in it, x and y are the points on the line, the actual the input to our function where we can stick in a number and the output where we get out our number. Those will always be x and y. The x1 and the y1, just like in the slope formula, are places where we're going to stick in a point that we happen to know. And so when we have our equation, as long as we know one point on the line, these two things together give us 1 point on the line, and then we can find the slope, we can write the equation of a line in this form. And so some of you have gotten to some questions in the Beyond and Advanced where they've given you 2 points and you've had to find the slope and then you had to go back and you had to figure out what b is somehow. When we're in this form, you don't need that specific y-intercept. You just need any other point on the line. So there's a lot nicer way of doing things sometimes. And you'll kind of see how this works, okay? So I'm going to go ahead and just put this up here. Y minus y1 equals m times x minus x1. And so what we're going to look for here is when we go to plug these things in, if I have the point 1, 2, remember this is x and y, that's not the x and the y, that's the equation part. Those x's and y's, those have to stay because that's the input and output of our function. It's the x1 and y1 that we're going to be plugging in here. So our x1 is 1, so we have x minus 1. And the y1 is 2, so y minus 2. And then m always stands for our slope. The slope is 3, so I'm going to plug in a 3 there. Now the best part is, before I even go ahead and do step 2, 3, and 4, I can graph the line here. If you want to go through the steps and graph the line at the end like it says, I'm going to do that too. But this right here, just by looking at this equation I have right here, that's enough to graph the line. Because I know that if I see this x minus 1 and y minus 2, it goes through the point 1, 2, and I can graph that. There's the point 1, 2. I also know that because there's a 3 here, the slope of my line is 3. And when we just see a number, 3, remember it's 3 over 1. So here that means I can go up 3, a little thinner line here. I can go up 1, 2, 3 over 1. That's a new point on my line. And so there's my line. Now, we don't usually in math like to leave point slope form. It's not one you're going to see very often. So what we're going to do instead is we are actually going to solve this thing for y and put it in slope-intercept form. And so that's why we have this practice at the beginning that you saw. We're going to start off by using the distributive property right here. 3 times x and 3 times negative 1. Just like in any other algebra case, we always want to write down the whole new equation, including the left-hand side. So it's y minus 2 equals, we're just distributing this side, 3x minus 3. we're not doing a step to both sides here. We're just simplifying. We're doing the distributive property on the right-hand side. So we've got this now. And then at this point, what I can do is I can isolate the y by adding or subtracting. I want to get to the point where this y is the only thing on the left-hand side. Well, I see y minus 2. The opposite of minus 2 is plus 2. So I'm going to add 2 there. I'm also going to add 2 on this side. Those will cancel out to leave me just y. And on the right-hand side, I can only combine the things that are alike. So the 3x is just 3x. I can't combine that with a negative 3 or a 2, but I can combine the negative 3 and the positive 2 because those are like terms. They're both just numbers. And so negative 3 plus 2 is negative 1. And now I'm right back into slope-intercept form. And in slope-intercept form, you'll remember that this is the slope and this is the y-intercept. So when we go to graph the line, I'm going to start by graphing the y-intercept at negative 1. Well, look at that. The line we graphed originally had a y-intercept of negative 1. Then I'm going to graph a slope of 3. And as we talked about earlier, if the slope is 3, it's really 3 over 1. So from that y-intercept, I'm going to go up 3 over 1. And would you look at that? I'm right back at the point I originally had, the point 1, 2. And you can see those are exactly the same line because all we did was rearrange the equation. And rearranging the equation, as long as we follow our rules of algebra, using the distributive property, adding or subtracting on both sides, it doesn't actually change the equation at all. And so I end up with the exact same line I would have had either way, just two different ways to think about it. And that's one of the really nice things about slope-intercept form, or point-slope form. We don't actually have to do all of this to be able to graph the line, but we usually like to because we like that slope-intercept form. Okay, let's do that one more time here with a little bit, more difficult numbers, I guess. So this one's got some negatives in it. And it's really important that we kind of see what's going on here. So I'm going to start off with plugging in my point, negative 2, 5. So negative 2 is the x-coordinate. It's going in for my x1. And the big thing here is this is going to be x minus negative 2. I'll put that in parentheses so I help remember that. This minus part is part of the equation. That's a negative 2, x minus negative 2. The y-coordinate is the 5, so that's going to go there, y minus 5. And then we've got the slope of negative 2. Before I even do any of this stuff here, I'm going to go ahead and graph that. So since I have this minus negative 2 and minus 5, I'm going to go ahead and graph the point negative 2, 5. My slope right here is negative 2. If you remember, a slope of negative 2 means negative 2 over 1. So it means I'm going down 2 and over 1. I get that point. And now I can go ahead and graph my line. Sometimes helps to do that multiple times. You're going to see as many times as I go down 2 and over 1, I always end up right back on my line. Now, before I go ahead and do step 2, a really common thing here is deal with that minus a negative. You see minus negative 2. Most of the time, you're not going to see that actually written out. You're going to see x plus 2 instead of x minus negative 2. But if you're dealing with point slope form, that's something you got to be aware of. So step 2 says apply the distributive property. So I'm going to take my negative 2. And I'm going to distribute it to both of these terms inside the parentheses. And I'm going to leave the left-hand side of the equation alone. Y minus 5 equals negative 2x. And then negative 2 times, we now have a positive 2, is negative 4. Then we want to isolate the y by adding or subtracting. Well, the y has this minus 5, and the opposite of that is plus 5. So I'm going to add 5 to both sides. Usually when I do this, I will write it right below the number I know I'm going to be able to add it to. I'm not going to write it below the x because I can't combine it with the x. I'm going to write it below the negative 4 because I can combine it there. So those will cancel out, leaving me the y alone. That's the whole point. Isolate the y. We get negative 2x. And then negative 4 plus 5 is plus 1. I don't know what I was going for there, but just plus 1. And now it wants us to graph the line because this is in slope-intercept form now. And so the big thing we're going to look for here, that's our y-intercept. That's b. And we look right there. There's our y-intercept right on the line. And our slope of -2, you'll notice, slope. You'll notice that -2 just stayed right there. It means we go down 2 and over 1, down 2 and over 1. And of course, we get the exact same line. If we don't get the exact same line, we definitely did something wrong. Okay, and this one's got some fractions in it, but that's okay. Same exact deal. This is our x, this is our y, our x1 and y1. So I'm going to plug the 2 in for x1, the 3 in for y1, and the 1/2 for our slope. I'm going to go ahead and graph that real quick before I do anything else. So you can kind of see if this is going to look the exact same. So I have the point 2, 3, which I can look from there and there at my x and y coordinates. And the slope of 1/2, which is also right there, means I go up 1 over 2. And you can see there's my other point. I can go ahead and sketch a quick graph of that line. Try to make it as straight as possible on the computer screen. That's pretty close. Okay, now when we go to apply the distributive property here, we need to be just a little bit careful with that fraction because we got to make sure we're doing that right. So we're going to take the 1/2 times x. So I'm going to start by writing the left-hand side. So 1/2 times x is 1/2 x. And then 1/2 times -2. I'm going to kind of go off to the side here and just remind you of what that looks like. It's -2 over 1, and I can multiply straight across. Well, 1 times -2 is -2. 2 times 1 is 2, and well, -2 over 2 is just -1. So this is 1/2 x minus 1. And then I can isolate my variable by adding 3 to both sides because I want to get rid of that -3. And I'm only going to be adding it to the -1. I'm only adding it once to both sides, but I can only add it to the -1 because that's my like term. And so I end up with y equals 1/2 x, and then -1 plus 3 is plus 2. And so when I go to graph this, there's my y-intercept. And you'll see right there at 2, I indeed have my y-intercept. There's my slope. I'll go up 1 over 2, up 1 over 2. You see it's exactly matching up with what I graphed originally. It doesn't matter whether I graph from any random point or I actually find the y-intercept. It's the same line. Doesn't matter which way I do it. Okay, the last example I'm going to do here is kind of one of the really big reasons for those of you that got to the beyond and advanced sections in the slope intercept questions. This is kind of the whole really nice thing about point slope form. None of that solving for b stuff that we had to do before. So we've got our 2 points. We want to find the equation of the line. We don't have the slope. So first thing we got to do, it's called point slope form. We need the slope. We have plenty of points. We've got 2 of those. We need the slope. So we're going to go ahead and do our y minus y, 3 minus 4, over our x minus x, so 3 minus 2. And so 3 minus 4 is -1, 3 minus 2 is 1, and that gives me -1 as my slope. So I'll go ahead and put that right in there. When we go to put in our point, it doesn't matter. Both of these are points on the line. You can pick whatever one you want. I'm going to go ahead and pick the first one because it's first. So 2 is the x coordinate, so it's going to go x minus 2. 4 is the y coordinate, so y minus 4. And that's our line in point slope form. Before I do all these steps, again, you could certainly do those steps first, but I'm going to go ahead and graph it with what information I have. Based on this equation, I know this goes to the point 2, 4. 2 is the x, 4 is the y. So 2, 4. I know my slope is -1, so that means I'm going just like before. If my slope is -1, that means -1 over 1. So I'm going to go down 1 and to the right 1. I'm going to do that a couple of times just to kind of get what that looks like. There we go. Okay, so now we're going to go ahead and put this into slope-intercept form because we like things in slope-intercept form. we're going to distribute our -1. So y minus 4 doesn't change. I'm going to put it down here. Y minus 4 doesn't change. We didn't do anything on the left. We're just distributing. We're allowed to distribute. Doesn't change anything. So I get -1x. And then -1 times -2 is +2. Last one here. I'm going to isolate the y now. And so I've got this -4 that I want to get rid of. I'm going to add 4 to get rid of that to both sides. Y equals -1x. Well, 2 plus 4 is 6, so +6. And then the only other thing here would be that this -1, we don't usually write -1. We usually just write negative. So y equals -x plus 6. And when we go to graph that, that means 6 is the y-intercept. So you see, actually, it doesn't quite fit on my line, but there, right on the graph, you can see that's where my line originally would have gone through. The slope is -1, which means, again, -1/1. So I go down 1, +1, down 1, +1. And you see I'm going right through those exact same points. It goes through 6 as the y-intercept. It went through 2, 4. It goes through 3, 3. If you go down 1/1 again, there's 3, 3. All of those points it's going to go through in whichever form we have. Slope-intercept form or point-slope form, both are the same exact thing. Okay, so at this point, I'm going to have the sub go ahead and turn off the video up here. If you want, this video will be posted on the Canvas page, and I'm going to continue on and just do 2 examples from the proficiency practice. So if you're getting stuck on a few of those, I'm going to do question 1 and question 3 so that you have kind of one more example of each of those. But like I said, I'm going to have the sub turn this off so you can work on the purple sheet, the proficiency practice for 6.6 with whatever time you have left. Okay, so if you're sticking around to watch this second part here, proficiency practice, the first thing they want is just the 3 things that we're going to need here. Slope-intercept form, that is our y equals mx plus b. We're going to try to end up with that on all of these. Slope formula, that's the m equals y minus y1 over x minus x1. That is just to find the slope. And then point slope form is the y minus y1 equals m times x minus x1. That is the other form of the line. So these 2 equations are forms of lines. In other words, the linear functions. Just 2 different ways to write them that happen to have some nice properties about them. You can write linear functions lots of ways, but these 2 are particularly nice. Okay, so we're going to give you these steps the whole way through this, I believe. And so you can kind of work through with those. So on this one, we have the point. It might be helpful to go ahead and just write x and y on there. So the x coordinate is going to go in for x1. The y coordinate will go in for y1. And the slope of -1 will go there. They even went ahead and left you directions on these. So the next step says distribute. So I want to see those arrows. And it would even help. I like to do that line. So as long as I'm distributing, I don't need to do anything to the left-hand side. But I'm going to distribute the -1 to get -1x. Distribute the -1 to the -2. -1 times -2 is +2. And then I'm going to isolate the y. To isolate the y, I'm just looking at that left-hand side going, okay, I see y minus 3. I'm going to add 3 so that I can cancel that out and end up with just y on the left. -1x, I'm going to go ahead and just write as -x instead of -1. And then I'm just going to combine my numbers. 2 plus 3 is 5, +5. So there's my line in slope-intercept form. So if I want to graph it from this form, I'm looking at my y-intercept of 5, plotting that on my graph. That's your starting point. I'm looking at my slope, which is the negative sign here. So that means it's -1 over 1. And so I'll go down 1 over 1, down 1 over 1, down 1 over 1. When I have a slope of -1 like this, I like to graph it multiple times just to help me draw the line in as straight as I can. A couple of things here you might want to look at. It should definitely still go through the point 2 comma 3, which it does. That's important. And if the slope here is not the same as the slope there, you mess something up. So make sure you go ahead and graph it. I'm looking for all of this work. I need to see it. It needs to look organized, and so I can follow it. Last one here. I would pause, do number 2 first, and then come back to this one. But on this one, we've got a little bit extra here because we've got to find the slope first. So I'm going to start off by reminding myself of the formula before I plug in the numbers. And again, I like to see this. I think it's helpful. It's helping a lot of you to not make some silly mistakes here. I'm going to draw these arrows in. So the y's, 1 minus 5. Oops, 1 minus 5. And then the x's, 4 minus 2. And that gives me negative 4 on top, 2 on the bottom, and I want to simplify that to negative 2. 4 divided by 2 is 2, and since one of them is negative, it's negative 2. So I'll put negative 2 in for my slope. I'm just going to go ahead and use the first point here. So since 2 is the x coordinate, it goes in the x spot. 5 is the y coordinate, it gets grouped with the y. If you need to look at these steps, go back to the first page. We just did the first step. Now we're going to distribute. Those steps will be written on your paper somewhere. You just have to go back and look if you need them on these later questions. So the left-hand side of the equation, I'm not doing anything to. I'm distributing my negative 2. So negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. And then I'm going to isolate my y variable. I see this minus 5, so I'm going to add 5 to both sides. It'll cancel out over here and just leave me with y, negative 2x, and then I can combine my numbers plus 9. Now you're going to see this one doesn't really fit on the graph all that well. But if I wanted to graph my line, an easier way would be maybe just to use these 2 points. 2 comma 5 is right here. 4 comma 1 is right there. And I can graph my line. If I kind of continue my y-axis up, I had 5, 6, 7, 8. We're close. My line's not perfectly straight there. It kind of curves a little bit, doesn't it? I'll have to make that look a little bit better. Do just a bit better here. So 5, 6, 7, 8, 9, something like that. But again, if you have those 2 points, go ahead and graph them. That'll tell you enough to have your line too. Okay, so at this point, I think you should have a couple more of these where you have to find the slope first. That's good practice of finding the slope. Make sure I see what you're doing here. And then when you plug it into the slope-intercept form, make sure I see the work to simplify it into slope-intercept form. Like I said, slope-intercept form both times. When you plug it in for point-to-slope form, make sure I see that distributing and the isolating for y for getting it in slope-intercept form. Those are the steps I'm looking for when we grade these. Okay, I'll see you tomorrow.